Hello and welcome to this first in a series of lessons on how to fly and fight in the P47 Thunderbolt. The P47 excelled as a high-altitude fighter but found a new role in low-altitude ground attack due to its airframe durability, pilot armor, and weapons capabilities. Pilots of its modern namesake, the A-10 Thunderbolt II, would feel right at home in the P47. I have the lesson paused so we can go over some key features and have a quick tour of the cockpit. The later lessons will go over aircraft startup, taxi and takeoff, landing, navigation, and of course, weapons employment. Go at your own pace and feel free to explore the aircraft controls as we go. We'll stay paused in the air so you will not break anything on this first lesson. It would also be a good opportunity to set up your flight controls and adjust control assignments to your liking. You can do that at any time by pressing Escape and selecting Adjust Controls from the menu. Press the spacebar when you're ready to get started. This is a large, heavy aircraft, weighing nearly twice as much as other single-engine fighters of its time, but the Pratt & Whitney R2800 double wasp engine more than makes up for that. This is a twin-row, 18-cylinder radial engine capable of providing over 2,000 horsepower to a four-bladed, electrically controlled propeller. It's equipped with a GE Type C turbo supercharger for increased performance at high altitude and a water injection system for up to 11 minutes of increased power for use in an emergency. This is an air-cooled engine, so it's not susceptible to liquid coolant loss and overheat when it takes damage. That's a big advantage while getting shot at. Press spacebar to continue. Flight controls are standard with a stick to control pitch and roll and a rudder to control yaw. Adjustable trim tabs are built into the left aileron, both elevator trailing edges, and the rudder trailing edge. Flight control surfaces are all metal to allow for a higher speed in a dive, and this model of P47, the D30, includes a new blunt-nosed aileron design to prevent flutter at high speeds. Wing flaps are hydraulically operated to increase lift on the landing approach and shorten the takeoff roll, and this model of P47 also includes dive recovery flaps that may be extended in an emergency to help recover from dives. Press spacebar to continue. This aircraft is a tail dragger, meaning it sits nose high on the ground on the two main landing gear and a single free swiveling tail wheel. The tail wheel is lockable in the fore and aft position to keep the aircraft aligned with the runway on takeoff and landing. The main landing gear are positioned very wide apart and provide for a very stable takeoff and landing roll and very good handling while on the ground. The aircraft is steered during taxi by application of the left and right toe brakes in the direction that you want to turn. Press spacebar to continue. The aircraft fuel system includes a 270-gallon main fuel tank below the front of the cockpit and a smaller 100-gallon auxiliary tank just below the cockpit. Both are self-sealing to prevent rapid loss of fuel in the case of battle damage, and extra fuel may be carried in external fuel tanks on the wings or the center line. The tank that supplies fuel to the engine is selectable from the cockpit. Press spacebar to continue. Electrical power is provided by an engine-driven 24-volt DC 100-amp generator. The generator does not operate until the engine reaches about 1100 RPM, but a storage battery is provided to pick up the load on the ground or in the case of a generator failure. The engine may be started using the aircraft battery, but it's more typical for the crew chief to connect an external battery for starting. Press spacebar to continue. Our P47 is the P47 D30, so it features a bubble canopy. This provides much improved visibility over the older razorback canopies on earlier models, especially to the side and the rear. A dorsal fin is installed on the rear of the aircraft to make up for the instability that resulted from the redesign. The canopy is left open during takeoff and landing to provide a greater chance of escape in the case of an emergency like a fire or tipping over, and the canopy glass may also be jettisoned by airflow during flight by pulling the handle to the right. Press spacebar to continue. Then of course we have the armament systems. 8 50 caliber machine guns are available, 4 in each wing, with a maximum load of 425 rounds per gun. The guns are aimed by a K-14 gyro sight. You set the enemy wingspan at just the range so the and the sight shows you the correct lead to pull for a hit. A fixed sight is also included as an additional reference. 3 weapon stations are available that make the P-47 a very effective dive bomber. Each wing station can carry up to a 1,000-pound bomb, and the centerline station can carry up to a 500-pound bomb. We'll look at operation of the armament systems in more detail in future lessons. Press spacebar to continue. Now that's a very broad overview of the aircraft and its systems, so now it's time to zero in on how they all work. A good place to start will be a left to right sweep around the cockpit to look at all the controls that are available. First, we have the carburetor air heat control. This can be used to provide extra heat when icing conditions are encountered, but is generally left in the cold position with carburetor temperature managed by the intercooler. Forward of that, we have a lever that either routes air through a filter or bypasses the filter. It's used mainly in dusty or sandy conditions that could have been encountered in North Africa or especially in Normandy in Northwest Europe, but it should never be used under icing conditions because the filter will ice up and cause a drop in manifold pressure. Press spacebar to continue. The flaps control handle is pulled aft to lower and pushed forward to raise the flaps. The center neutral position is used when milking the flaps up or when full flaps are not used. Otherwise, the handle is left in the up or down position to equalize the pressure on each side of the system. The flap position is judged visually by checking the markings on the outboard of the flaps themselves, and you can easily see those from the cockpit by looking left and right. Press spacebar to continue. Below that are the trim tab controls. The indicators are marked left, right, tail heavy, nose heavy, neutral, and takeoff. These will be used almost constantly in flight as conditions change, so it's best to map these controls to a convenient place for quick access. The emergency hydraulic pump handle is used to manually supply pressure directly to the system for operation of either flaps or gear in the event of a pump failure. Press spacebar to continue. Now moving forward, 2 switches control the position of the intercooler and oil cooler air shutters. Their positions are marked closed, neutral, and open on the indicator just to the left. For takeoff, both shutters are set to neutral, and in flight, these are managed to control oil and carburetor air temperature as indicated on the main instrument panel. Press spacebar to continue. To the right is the canopy open and close switch. You may also open and close the canopy manually using the handles on the left and right side. Then just below is the guarded gun and camera switch. You'll need to open the switch guard, then position the switch down to the guns and camera position to fire the guns. Then just below that, the landing gear control is pulled up to retract and down to lower the gear. Press spacebar to continue. The fuel selector switch is marked with 3 positions: main, auxiliary, and external. The engine receives fuel from the tank that is selected. The 4th unmarked position functions as an off switch. Then to the right is another switch to select the appropriate external fuel tank if installed. The switch only functions with the fuel selector set to external. Important operations like takeoff and landing are carried out on the main tank. Then after takeoff, the best flying qualities and center of gravity are achieved by running down the external tanks, running the auxiliary tank down to a safe reserve of about 10 gallons, and then switching back to the main. Also, some extra fuel bypasses the carburetor and returns to the main tank, regardless of the fuel tank selected. That means you'll need to run on the main tank for 10 minutes after takeoff to create enough room to prevent overflow. Then, run on the main 10 minutes every hour for the same reason. Press spacebar to continue. Next, we come to the throttle quadrant with its 4 levers that regulate engine performance. The first control is marked B, boost, for use of the supercharger or turbo. This lever regulates the amount of supercharged air routed to the carburetor to provide extra power for high-altitude flight. It's normally linked to the throttle using the latch at the base of the lever and should never be pushed forward of the throttle while in flight. Otherwise, the turbo could be damaged by pressure buildup that has no means of escape. The second is the throttle, with a water injection switch on top and a mic button for communications on the side. The throttle is used to set the desired engine manifold pressure and is the primary means for controlling engine power in flight. The throttle grip itself can be rotated and is used to control the range setting of the gun sight. We'll look at operation of the gun sight in more detail in future lessons. Press spacebar to continue. The third lever, marked P, is the prop RPM control. This lever sets the propeller governor to the desired engine speed. Like the supercharger lever, this may be linked to the throttle using the latch at the base. And then the fourth lever, marked M, is the mixture control, with 4 positions marked idle cutoff, auto lean, auto rich, and full rich. Normal operation is with the lever set to auto rich, with the auto lean setting only used for long range cruise, and then full rich is only used if the auto rich setting fails. Press spacebar to continue. Now moving just forward, an electrical control panel provides a backup ability to control the propeller RPM in the event the prop lever on the throttle quadrant fails. The switch is set up to the auto position for normal operations, and prop RPM is then controlled from the lever on the quadrant, but the switch may also be set down to an emergency fixed pitch setting. Toggle the switch forward to increase RPM and toggle aft to decrease RPM. A circuit breaker pops out to show a red color when the circuit is overloaded. The propeller remains in the last position until you push the breaker to reset, and of course the breaker should be in for normal operations. Press spacebar to continue. And next, if airspeed is too high in a dive, shock waves may form near and on the control surfaces that prevent them from moving. This is known as compressibility and is to be avoided, but if you do find yourself in that situation, the recovery flap switch may be positioned down to extend recovery flaps under the aircraft. The flaps increase drag to help control the speed and pitch the nose up to aid in recovery. Press spacebar to continue. Moving down, we come to the main electrical control panel. Switches and circuit breakers for most of the electrically controlled systems are located here. The gun sight and compass light rheostats control brightness of those bulbs, while the instrument rheostat controls the illumination of the dials and lettering on the instruments on the front panel. The instrument lettering is UV sensitive and glow in response to the UV lamps mounted on the left and right of the instrument panel. Exterior lights on the wing and tail may be set to off, dim, or bright, and the landing light may be extended or retracted using the switch. There's also a conventional cockpit light that may be turned on and off. Then just below those are switches for test of the landing gear warning, fluid level, oxygen warning, and turbo warning lights. Press spacebar to continue. Next, we have a rheostat for emergency control of the fuel boost pumps. It's normally set all the way to the left in the start and altitude position, but may be rotated clockwise to manually operate the pump in the case of low fuel pressure. Then the last switches on the panel connect the electrical generator to the circuit, turn on the pitot probe heater, and operate the oil diluter. Now the probe heat switch should be turned on when airborne to prevent ice buildup on the air data sensors, the pitot probes, that may interfere with airspeed and altitude readings, and is turned off on the ground to prevent overheat. Then the oil diluter injects gasoline into the oil to increase flow and is for cold weather operation only. Press spacebar to continue. And then finally, we come to a series of circuit breakers that can isolate aircraft systems in the event of a malfunction. These automatically extend if an overload is detected and must be pushed in to reset. Each breaker is marked with its applicable system. Press spacebar to continue. Now moving up to the main instrument panel. The main flight instruments are all conventional. We'll look at these as needed in future lessons, so let's look at the items that are unique to or may work differently in the P47 from other aircraft. At the bottom left, we have the battery switch. This is normally left on after startup to connect it to the electrical system and allow it to charge. It should be turned off when using a battery car to start the engine. Below that is the ignition switch marked off, L for left magneto, R for the right magneto, and both for both mags. The magnetos are inductor coils that produce the high voltage required by spark plugs to ignite the fuel in the combustion chamber and run the engine. Press spacebar to continue. Moving up, we have the landing gear warning light, which will glow red when the gear is not up and locked, down and locked, or when the gear is not down and locked with the throttle 3/4 of the way closed. Then on the right side of the instrument panel, we have the starter switch. This is pushed down to energize the starter flywheel. Then when the flywheel is up to speed, the switch is set to engage to transfer that energy to the engine and turn it over for the engine start. We'll see more on this in the next lesson on aircraft startup. Press spacebar to continue. The fuel level warning light flashes when approximately 40 gallons of fuel remain in the main tank. The compound fuel gauge just to the right of the light shows auxiliary tank quantity on the left and main tank quantity on the right. There are no gauges for the external fuel tank, so those are switched off based on elapsed time and your estimate of the quantity remaining. Press spacebar to continue. At the top right, we have the turbine overspeed warning light with turbo RPM just to the left. This light will glow steadily when the supercharger RPM exceeds the redline value of 22,000. Pull the supercharger boost lever back when the light comes on. Press spacebar to continue. We have already seen the K-14 gun sight at the top, so let's move on down to the parking brake control at the bottom of the panel. To set the parking brake on the ground, pull the knob, depress and release the brake pedals, then release the knob. Then, on either side are jettison handles for the two wing and the centerline store stations. You simply pull the lever for the station you wish to jettison and the hooks will be manually released. Then below the handles are the switches for the normal electrical arming of the three stations. When the switch guards and switches are raised, the stores will be released when the bomb release button on the stick is depressed. You can release stores singly by only arming the desired station or simultaneously by arming the stations you wish to release. And typically, the two wing store stations are released simultaneously to prevent controllability problems with an asymmetric load. Two chemical tank arming switches are available to allow spraying of things like smoke screens or tear gas from tanks hung on the store stations, but are not used in this version of the P47. Press spacebar to continue. Now let's move on to the right side of the cockpit. Just right of the instrument panel is the engine primer. This will be used to introduce a small amount of fuel into the combustion chambers to help with engine startup. Then below the primer is the cowl flap control. Pull the knob to open and push to close the flaps. There is no gauge for the cowl flap position, but you'll be able to see it very easily looking straight ahead. Press spacebar to continue. The recognition lights panel controls three colored lights below the right wing. They're used to inform ground and air defense crews that the inbound aircraft in the dark sky is friendly. The lights are off with the switches in the center position and on steady with the switches up. You may also set the switches down to the key position and use the keying switch to blink out different sequences as prearranged signals. Earlier models included a white upward recognition light on top of the fuselage. The control remains in this model, but the light itself was eliminated. Press continue. Next, we come to the oxygen demand regulator. This provides you with breathing oxygen at high altitudes. The switch is normally left down in the normal oxygen setting, marked yellow. This mixes the onboard oxygen with normal air at a rate based on altitude. There's also a 100% oxygen setting, marked white, that opens the regulator regardless of the altitude. Be careful not to use this unless necessary though, as it will deplete your supply quickly. There's also a valve for emergency use that completely bypasses the regulator. Press spacebar to continue. The SCR-522 radio is equipped with 4 frequency bands, or channels, A, B, C, and D. Simply push the button to select the channel you wish to transmit and receive on. The function of each channel is usually listed in the mission briefing. Volume can be adjusted using the knob at the front, and at the end of the set is a master toggle switch marked T for transmit, R for receive, and REM for remote. The remote setting is used most of the time and allows transmission when the mic button is pushed and receiving at all other times. Setting the switch to T transmits continuously and can jam the channel, so a locking lever may be set that returns the switch to the R position unless held in the T position. Then, just below the radio, we have a cockpit vent that's pulled out to force cold air into the cockpit. Press spacebar to continue. The Detrola radio set above the map case is a low-frequency set for receiving only from 200 to 400 kilocycles. It's used mainly as a backup in case the main radio fails. You can manually tune the desired frequency using the dial and adjust the volume using the knob. Then, just after the Detrola are 2 buttons used to detonate the IFF, identify a friend or foe, equipment. Pushing both buttons simultaneously sets off a detonator in the IFF receiver located in the back of the aircraft. Press spacebar to continue. Then finally, the tail wheel lock is pushed forward to lock it fore and aft, and pulled aft to allow it to freely swivel. We'll work with this in the lesson on taxi and takeoff. Now, that was a lot to take in, but becoming familiar with the cockpit layout and basic systems will help the next lessons go much more smoothly. We're going to pick up next time with the aircraft on the ground, ready to start up and walk through that procedure. For now, though, you may unpause the lesson and continue to look around by pressing the spacebar, or you may end the lesson at any time by pressing the escape key.